Hello and welcome to Learn Yourself. Today we are going to learn about reducing nature of ammonia. This topic is under chemical properties of ammonia from the ICSE 10 standard syllabus from the chapter number 7 C Study of Compound Ammonia. In my previous videos we have seen physical properties of ammonia, chemical properties of ammonia. Into that we have seen the basic nature of ammonia, how the ammonium hydroxide we are using in qualitative analysis. All those things we have learned till now. So today we are going to learn about ammonia we are using as a reducing reagent. So how it is working as a reducing reagent. Before that we need to understand that what is a reducing reagent. Reducing reagent means the reagent or the compound which will help compound to reduce. Now what is a reduction or reduce means? Reduction is a process when compound is losing their oxygen. So when copper oxide will become copper with or in the presence of ammonia, then ammonia will be our reducing reagent and copper oxide is getting reduced and becoming copper metal. So this is a reduction reaction in which copper oxide is going to lose oxygen. When they are losing oxygen, then it is reduction. So in this reaction we are going to reduce two compounds, that is lead oxide and copper oxide. Let us first see the reaction, what is going to happen in this chemical equation. So in this, whenever the copper oxide will react with ammonia, we will get copper metal and we will get water and nitrogen. This is our reduced product. These two are our reduced product. Along with this reduced product, we will get these two. So when ammonia is reacting with lead oxide, we will get reduced lead and this two product. So when we are heating these two, after passing a dry ammonia gas from this tube, we will start heating this tube. Into this I have kept lead oxide, into this I have kept copper oxide. So while heating this we are passing dry ammonia gas. So dry ammonia gas will pass through this tube. So this tube will start converting into lead and copper. Along with this reduced product we will get water and nitrogen gas. So how we are collecting this two is, so from this pipe the water and nitrogen gas will go to this U-shaped tube. This U-shaped tube I have dipped into a water bath. So whatever water vapor will come here will cool down by touching this cool surface of U-tube. So this U-shaped tube will contain a condensed water, because whatever water vapor will come here and it will cool down and we will get a liquid water form. Now whatever gas will be there, that will remain here, and once this tube will fill, that gas will go to this gas jar. This gas jar I have inverted and dipped again into a water bath, and when the bubbles of nitrogen gas will come out, we are collecting nitrogen gas here. Nitrogen gas is not soluble in the water. So the nitrogen gas whatever we are collecting is by downward displacement of water. As the bubbles are coming out, it will occupy the space and water will go down. So here we are collecting water, whatever we are getting from the equation, and here we are collecting the nitrogen gas. And at the end of reaction, whatever black copper oxide will be there will convert into brown copper, and yellow lead oxide will be there, will convert into grayish lead. So in this reaction we can say that ammonia is acting as a perfect reducing reagent. With the help of ammonia we have reduced two oxide, that is lead oxide and copper oxide. So this is the effect of ammonia as a reducing reagent. One more reaction we will see. This is for a reducing action of ammonia, which is converting chlorine gas into HCl, converting chlorine gas into hydrogen chloride gas. Now let us see that reaction. When ammonia is reacting with chlorine in excess, then we will get 3HCl and NCl3. NCl3 is nitrogen trichloride. So what is a reduction? Reduction is not only a removal of oxygen. What we have seen in earlier reaction, that copper oxide will convert to copper. We said that this is a reduction reaction and copper oxide is reduced to copper. Reduction is also an addition of hydrogen. So when we are adding hydrogen to any compound, that is also termed as reduction reaction. So when Cl2 is there, chlorine gas is there, it is converting into hydrogen chloride gas. Then this is termed as a reduction reaction. So reduction reaction we can understand by two ways, that one is removal of oxygen and other thing is addition of hydrogen. So this both type of reaction are considered as reduction reaction. So the second type is happening into this, that when ammonia is reacting with chlorine, we will get hydrogen chloride gas and nitrogen trichloride as side product. So this is all about chemical properties of ammonia. We have seen a basic nature of ammonia, reducing reagent ammonia and catalytic oxidation of ammonia. In my next video, we are going to learn about identification test of ammonia and its uses. Stay tuned and don't forget to subscribe my channel. I'll see you in next video.